Hello, and welcome to another outstanding edition of Western Bachelor, or Western Alaska Bachelor. I'm here today to discuss kind of some of the pros and cons, hiccups, and learning experiences we've had in our first approximately 6 to 10 weeks of production here in our new aquaponics system. I'm going to emphasize mostly technical aspects of the system, pumps, lining materials, filter materials that we've run into and encountered, and then we'll have another video here emphasizing more of the biological, ecological aspects of the system. First and foremost, everything seems to be working pretty well from a pumping standpoint. We now have our full 2 pumps. If you look over here, we have a 1,250 gallon per hour pump at approximately 8 feet of head height. And over there, we have approximately a 400 gallon per hour pump at about 8 feet of head height. Both of those pumps are piped using 3/4 inch PVC Schedule 40 pipe, and they all come over 2 separate systems. They all come over to about right here, at which point each pipe, each run from each pump splits, and the majority of the volume coming through goes through our filter. Again, this filter is about 4 inches of pea gravel. That's about 1/2 inch sieve-sized pea gravel. Then maybe another 8 inches of sorted sifted perlite for larger particle size. And at the bottom, 3/4 inch wash rock gravel. In here again, this lower filter, most of the water is pushed through the lower filter. That's almost all gravel. And then we have a little bit of oyster shells on top for pH buffering. And pH is one of the issues we'll talk about in our other video when we talk about the ecological and biological systems and how they're doing. As you can see, the goldfish are doing well. Most of them are getting bigger. We've only had a few die, and most of them we've lost from the ducks eating them. So we still have about 40 goldfish, and that seems to be sufficient, more than sufficient for our system. In an effort to increase the surface area available to the microbes and bacteria, we've added essentially pea gravel filters where the water flows into the system. You'll notice that the vast majority of the volume of water that each pump is pumping is going through the filter system in the fish tank. The fish require much higher volume turnover of water than the plants do. The plants don't need more than maybe 100 gallons per hour tops, whereas the fish tank is getting probably around 600-700 gallons per hour. And this modified gravel filter, we're planting watercress in. So we're trying to kill 2 birds with 1 stone. We've had issue with plants falling over. All the seedlings were raised in an environment where we had an oscillating fan providing wind, so it created strong stem growth and whatnot. So we're adding circulating fans, oscillating fans to the system to try to create kind of a moving convective action, kind of a cyclone through the whole facility to prevent those plants from toppling over. One interesting issue we had is the outflow from our fish tank into our main sump. The outflow from this pipe, if you look down here where it flows into the sump, this outflow flows into the sump at a water level not too high above the tank. And one day we were filling this sump with water because the system has a slow leak. And what happened was a siphon formed through the actual outflow line and ended up draining about half the volume of the fish tank because the actual inflow filter in the fish tank is approximately 1 foot below water level. You can't see it down here, but basically there's a modified trash pump strainer. And the reason we did that, the reason we don't have the water just flowing out at surface level, is that way fish and plant material and plant and fish food would just float right out of the fish tank. So our intake for the outflow is below water level. Anyway, it created a siphon, so in order to prevent that from happening in the future, I drilled about a 1/8 inch to 1/4 inch hole here in the top of the PVC to prevent a siphon from occurring again. Because again, our whole system is set up so that if power goes out or something fails, our fish tank isn't going to be pumped out or drained automatically. That's why we use a separate sump tank, and that's why the pumps are in that sump tank. Plants can live just fine for several days without water circulating, but the fish will die quite quickly without oxygenation and without fresh water supply. Another technical problem we've had here is you'll notice if you look straight down, this floor surface is wet. And what we tried to do is we tried to take two different pieces of this EPDM fabric. We're using 45 mil EPDM fabric. This is 45 mil EPDM pond liner. You can buy it online. Firestone makes it good. Make sure that you get the fish safe pond liner. Don't just buy regular frac pit pond liner or something designed for roofing. Make sure it's fish safe, food safe. Anyway, for our sump tank down here, we tried to seam two different pieces, and the seam did not go well. We found the seams work well when there's not a lot of water pressure, but where there is some water pressure, for example, under 8 inches to 12 inches of water, we do get leaks. So we bought a single piece, and we'll be replacing this pond liner shortly. Other than that, our lights, you can see we're mostly using T5 fluorescent lighting with grow lights. We've got a couple LED multi-spectrum grow lights for the corners. We found that 4 foot by 6 bulbs wide with, you can select, use more or less bulbs to maximize your specific efficiency with your fitting has worked well. And light fixtures that are daisy chainable, that is, that have a plug as well as an outlet plug on them, seem to work really well. It's been very convenient for us. We've also set up each different circuit in the room on separate breakers. We use shot breakers. And then all of our time stuff, like lighting, is run on mechanical timers. We prefer mechanical timers to digital timers. That way if the power goes out, you can continue to have a certain measure of system stability. It doesn't just reset like your alarm clock does if the power goes out. The timer continues to rotate with the mechanical timer. Again, here's the downflow from an upper bed. You can see we've got more of a modified tea gravel filter in here. And this just adds to our surface area for microbial action in addition to the filter that's above the fish tank. We have had a lot of clouding from tannins and other mixtures that have gotten into the system from the soil that we're using, and we've had a lot of algal growth as a result, so our snail population is not quite keeping up with that, but that's something to look for and something to think about if you build a modified system like this, a hybrid aquaponics and soil-based system. At this point, though, those are our major technical hurdles. I think we're overcoming them in stride pretty well, and as you can see, the system's yielding well. And I'll put more about the ecological stuff in the next video. Thanks for watching.